This conference will now be recorded.
Sorry.
If there's no other topics, then we could use those and see how much interest there is in having an open discussion in those areas. Does that make sense? And if folks didn't receive the email, I'm happy to show it if you like. Or you can.
Why don't I make you a presenter and then you can just go ahead and recap, Tom?
Sure.
Okay. You should have.
I'm going to test my technology acumen to see if I can actually present something, right?
Yeah, you should get a prompt that shows up, and you can either share your screen or share the application.
Yeah, I think I'm sharing just one little window.
Yep.
On email.
Yep, we're seeing your email.
This is the email I sent out earlier, and just as a recap, as soon as I finish making this introduction, I'll ask for agenda items if there are folks who'd like to bring one forward. And if not, I've got some suggestions there in the 1, 2, 3 bullets of areas that we might talk about, how Telco can support some of the initiatives that OCP is looking to pursue to make OCP more relevant, more usable, more valuable for our adopters. And the big one here that you see in these bullets is modularity, and that by having common modules that we might reuse across designs and projects and so forth, that there might be value in not doing rework. And so I got a couple of those there that we might just have a discussion around. So with that, I'll go back to what I said earlier. Are there any agenda items that folks would like to either add to my list or bring up as a separate area, or would like to consider for discussion today? And this is the awkward silent moment, right? Hey, there we go.
Hi, everybody hearing me? Or somebody hearing me?
I hear you. That sounds like Paul.
Hi, Tom. This is Paul. Yes, really. I just seen open discussion. It sounds good. And you mentioned timing, BMC and timing in your modularity in telco designs. I have a relatively simple question, but maybe that has a larger impact. As I understand that OCP is hosting Open Network Linux, I have the impression that the timing, for example, is not at all present yet in ONL. So are we thinking about including the control for timing in ONL? That would be my short question.
That's a great question too. And I'm not aware of that having happened. So I would suggest that we bring that up as we talk about timing and modularity, because as you point out, modularity is not just a hardware thing, but also a software thing. And control over timing modules in ONL makes a lot of sense, right? Okay, any other agenda topics folks would like to suggest?
Hi, Tom. This is Jim from the Pegatron. Regarding the suggestion for the timing support in ONL, there may be another choice. Could be the AT&T contribution, Dynos.
Yeah.
I don't know if AT&T plan to contribute Dynos into the OCP.
So AT&T has contributed work we've done in Dynos to the Linux Foundation. And so it is already an open sourced OS. And it is something, it's a great question. I honestly don't know if it makes sense to have it both available from the Linux Foundation and also through OCP, or if just having a linkage or pointers between the communities would be helpful. I don't know if that helped your question, Jim, or
Yes,
not.
Tom. Yes, I just want to point out. I believe as far as the timing support should be already in the diagnose, right?
Hmm.
Okay.
You know, I don't know that Danos has timing support because the original systems that it was built and used with, to the best of my knowledge, don't have critical timing augmentation, right? They might support sync E, but they don't have what I would call timing hierarchy, holdover circuits, or any of those types of things that that might be used in Sonnet or front haul or radio over Ethernet or any number of networking applications where really tight timing requirements are critical. So it may be something that still needs to be added to Danos from my understanding, or something they're working on. I honestly don't know.
Yes, this could be. Recently, I learned that the AT&T work with the IP in Beijing to support the DNOS on the cell side gateway, which I will assume that the timing should be support already, according to the announcement.
Ah, okay. So that you're right. That might be something that's available in Danos. Thank you for bringing that up. I didn't know that.
Okay.
Hey, Tom?
Yeah. Is that
on
Michael?
on your subject number 2, I'm a member of the PICMIG committee that's doing a new version of the ComExpress boards, especially for high performance computing.
You don't know how that warms my heart just to hear that. So I think we'll have a good discussion on number 2.
Okay.
Excellent. Okay, so I don't hear additional topics. Why don't we just go through these 3, the modularity, and then the CPU module in particular, and then we've had discussion in the past when we talked about the universal CPE about using NIC3 form factor for WAN interfaces, right? It's hot pluggable and has and that's kind of interesting, where a lot of NICs in the past would have required opening boxes. And so NIC 3.0 has a lot of characteristics that are similar to what networking equipment has traditionally had. So winding it back up to the beginning, why don't we just go through in order. Modularity in telco designs. So this is here, and it's a shame that Sumitra can't be here because I really need to give her the credit on number 1, that in discussions that we've had around the work that AT&T has been doing, it's kind of become apparent that there are certain components that get used and reused on lots of different network element designs, everything from universal CPE to cell site routers to Ethernet switches and to the large, scalable core router design that was contributed or that was presented in Amsterdam. And the areas that make a lot of sense, we think, that we could talk about to begin with include the BMC, timing, and the CPU. And there might be others. That's why et cetera is there. And I'd like to sort of poll the folks on the call. From our perspective at AT&T, we like including BMC on network elements because we want to have more and more capability to do what we call virtual truck rolls, to be able to do low-level manipulation of network elements without having hands-on. And the BMC is uniquely available for doing things like, completely reinitializing a dead system, being able to turn on and off these systems. For example, we've determined a lot of times you have to be able to do power cycles in order to update certain types of firmware. And so we think that BMC, from our perspective, with our our own costs and operations winds up being a positive case to include in our designs. But we've also seen that in many other locations, people are not necessarily so bought into having a BMC, and that perhaps using BMC, like Run BMC has been created as a module that's an optional add-on, might be a great sort of common way to bring common BMC capabilities as options to a lot of kinds of designs. And the same logic, frankly, applies to timing, where the types of switches that we make use of might be used in some cases in data centers where the timing is not at all critical. And in other cases, the same kind of basic motherboard layout might be quite useful in let's say a wireless front haul application where timing does become critical. And indeed, even in many cases where timing is needed in every case, the accuracy of the timing might be varied from one application to the other. And therefore, we thought that having the timing, the oscillators and so forth that are used for those circuits as common modules might make sense. And then lastly, the CPU, what we have are multiple applications where in some cases we ask a white box or an OCP box to be a standalone device. And so the CPU in that device needs to be able to support the management and control plane functions and all of the low-level functions as well in that box, just like traditional boxes have been for a long time. But in other cases, and a good example there is when we talk about OLTs, we often expect to deploy many of those side by side, and we think that there could be benefits and efficiencies by putting lower end CPUs in individual boxes and then having common management and control plane in dedicated servers that are outside of those boxes. And if anyone's familiar with the CEBA architecture from the ONF, it follows exactly that pattern. So what that means is that the same box might be asked to have a high-end CPU or a low-end CPU, and therefore the modularity would make a lot of sense in that environment. Is that making sense to folks on the call? Are there any comments or questions about that? And especially, do you think there are other areas where modularity would be helpful for telco designs?
So I'm gonna start here, Tom. This is Dirk Levins from Intel.
Hey, Dirk.
And
I know you.
You might know me at a time or two. So I do agree with where you're going to on these elements of modularity. What I do have concerns about is if we're trying to develop a single solution that defines things that's going to hit various cost points, sometimes modularity actually increases cost of the base solution. And let's just take timing as an example. You may be able to remove, essentially the GPS timer or things of that nature from the system. But, at the end of the day, you're still going to have Ethernet controllers and things like that that's going to allow you to be able to do in-band timing recovery as well. And you're likely not going to want to swap those particular things out, when you build out these systems. So I think that's something that you got to balance as we provide a solution, that we think about how we implement these to create the least amount of system cost impacts, so that ODMs and OEMs can build essentially off-the-shelf solutions that can be cost-effective for that lower CPU, type implementation and lower cost implementation without all the bells and whistles to it, as well as the higher-end solution, if that makes sense. And I think those things can be achieved, just FYI, but it may take us moving off the beaten path.
Mm-hmm.
Does that make any sense?
I don't know if I really got all of what you meant to say there. It seems like if I understood correctly, Dirk, that the modularity from the fact that you are creating piece parts and connectors that will allow them to be modules, and then also need to do integration and testing, because it also begets or suggests that there are multiple options, not just one, that it may add complexity and cost to especially to very simple systems. I think
you got it.
That's
exactly all I was
with you with that.
Yeah, that's all I was trying to say. That's a word of caution we need to be careful of. I think other things we need to consider are TPMs. I think TPMs are optional in some cases and not in others. That's one I can think of immediately. I also think that we should consider I/O scalability as well, because I think for each of these boxes, we find that different geographies require different I/Os to be able to be deployed. I know, Tom, this is something that you've been hot on for 5 or 6 years, in our conversations, because some geographies may require a DSL interconnect, some may require a PON interconnect, some may require something else, so some level of I/O modularity to allow that flexibility, I think, is important as well. So.
I agree. I agree. And you can tell number 3 is kind of me bringing up the old topic again. So that's it. And, I would add one other thing. And for folks who might not have known this, the existing draft specs that we've been working on for G.fast DPUs have this concept of a BMC that is not a discrete component, right? That a DPU is a very low-end device. It's basically a small single board that would be placed in outside plant, and in fact, a lot of times we look to support its control and management software in one of the ARM cores that are a part of the SOCs that make up the G.fast or the GPON or XGS-PON PHY solutions. And so when we were developing that spec, one of the things that we thought, we still like the idea of BMC and the fact that it can sort of harmonize operations for a carrier. And one of the things we put forward is that instead of using a separate discrete BMC, that BMC functions might be sort of built in as part of the basic firmware of the device. And so it's not as robust as a completely separate BMC, but in applications like that one, which I think is where Dirk was going with his example, some very low-end devices might look to do innovative solutions that provide capabilities in alternate ways. And that's one I would cite as an example. Okay. So I think that, the so what about having the discussion, other than getting people all sort of educated and thinking about this, is whether or not we as a project, a telco project, would consider, having a reference module that if you have a design, let's say we come up with a design for a top of rack switch. How many of those have we seen, right? Lots. And let's say, for example, the top of rack switch includes all 3 of these modules. Would it be valuable that there be a kind of a reference or a common module from which each and every manufacturer could draw? Or, if there's more than a few manufacturers on the call, do you manufacturers actually think that you're better off and have more control over your designs and their robustness if you wind up making your own modules? In other words, there'd be one from each and every ODM. However, they all have or meet sufficient requirements that they operate and they behave similarly enough that they don't require separate tooling when they're put into service. Was my question too long and drawn out to get an answer?
I understand the question, Tom, but I don't want to be the only one to respond. So.
Well, from a manufacturer's point of view, Tom, I understand the question. I think it's a good question. Speaking from an ODM company, most ODMs do think they have some value in their own type of CPU module designs. That value may be differentiation in features or performance, or cost savings, or both perhaps. But I think those values they see are minimal compared to the scaling and eventual cost reduction, ease of designs if we standardized on some type of, perhaps just an interface for the timing modules and the CPU modules,
right,
such as Run BMC did, and start with that. I think that's totally in the right direction.
Okay. So that sounds very promising, and that there's a great opportunity here for us in the Telco project to kind of pull some of this together and help everyone along the way.
Yeah, no, I agree. I think these, low level, if you come up with some interface specifications, much like the Run BMC, it could be shared across all groups, not just Telco, the networking group as well. So.
Yep, I agree. Okay. Any other opinions? If not, I think we could move on to item number 2, right? And does that sound like a plan? So here we go. In the design that AT&T pulled together for the large carrier router, no, I should start before that. Before that design, we have created specs that included ComExpress Type 7 for a number of different designs that we put forward, and we thought that the work that had gone on in the industry to come up with the ComExpress series of boards made a lot of sense and was potentially unifying. But then we also had noticed that a lot of the existing top-of-rack switches, for example, and other designs at OCP didn't always make use of ComExpress, right? That some did, but a lot of times there were I can't call them proprietary, right? Because they were part of an OCP contribution, but they were unique designs for these modules. And I guess the question comes forward, what's driving that type of activity? Is it that, the connector, I'm just grasping at something here, is it that the connector is expensive and using, Goldfinger connectors would be a much cheaper solution for a typical ODM? Or in one case, I have learned from an AT&T design that the existing form factors for COME 7 weren't large enough for some of the things that we wanted to accomplish on a CPU module. And so for large-scale router boxes, like the ones that we've been talking about or contributing and presenting on, there's a need for much more memory than you typically get with a pair of SODIMM modules. And so being able to host a pair of full-length DIMMs was important to us. And then also, there was the notion that having a pair of M.2 SSDs was another thing, that we've seen enough failures of SSDs in the field that we'd like to keep, the kind of RAID 0 kind of mentality around the base OS in a network element. And that by the time you added 2 full-length RAM modules and two M.2 SSDs, we're getting to a fairly large module. And so there was some discussion around should there should we try to push for a new kind of module that would be fairly much larger, or should we try to convince the folks, who do the Com Express to support, a supersized variation as well? So I'll pause there because I'll bet money that Michael's got something to say.
I can read you the introduction to the COM HPC, which is high performance computing spec that's in development right now. That has a list of what changes are included in this spec. And the first one on there is significantly larger form factors. They've got a newer connector on it that's got 3 times the bandwidth, so it will handle 32 gig PCI Express on it instead of just 10 gig. Let's see, it will support 8 full-size DIMMs, so that should keep you happy.
Yes.
Or 4 SO DIMMs, up to 150 watt CPUs. Let's see, 8 25 gig Ethernet connections. Let's see, there's a bunch of other things on the DisplayPort and DDI and HDMI and stuff like that that you're probably not interested in. They've got provisions for putting an FPGA on the COM Express module and GPUs, and also for supporting non-x86 style CPUs like ARM CPUs. Anything we missed that you wanted?
No, I think you nailed all the things that I'm aware of that that were given us agita with COM Express 7. I think you've ticked off.
Just one tiny question here. Is there provisions to do the BMC on the COM Express board, or is the BMC to be always on the main board?
That's under discussion right now, and there's pros and cons for both locations. I don't think it's been completely decided where it's going to go yet.
Probably not reasonable to foresee 2 placement options in one design. So have a connector on the switch board and a connector on the CPU, the COM Express board.
I would imagine that they're going to pick a location for it, but I don't think that's been completely resolved yet. Yeah, because one of the diagrams that's in here shows provisions for a BMC both on the COM Express module and on the COM Express carrier board. And I don't think you need both. So I think a little further down the road they'll pick one as the preferred locations.
Okay.
Question here on backwards compatibility. What elements of backward compatibility will exist in the new form factors, new designs?
It's a different form factor and a different connector. So I would say architecturally it's going to be very similar, but they're not going to be physically backward compatible.
All right. So you're basically supporting the new COM-E in a design, and I guess you have to make a decision whether you support the new spec or the old spec.
Yeah, because a lot of people were pushing for faster than 10 gig Ethernet connections, and the original connector on it won't support it. So there's a new connector that's under consideration for this right now that will support the 25 gig connections that people have been asking for.
Okay, yeah, definitely I can see the benefits there. It's something we're looking at, and saw the limitation in the existing connector as well.
Oh, that's cool. And it is interesting, and I can see why it was put forward as a HPC variation. I think we just saw a contribution come in to OCP around around this type of capability where ComExpress cards were used with carriers and then racked into to become basically blade server type of systems. And that's very interesting. Okay.
Well, if you've got any features that you really think you need, then you can forward the list off to the PICMIG ComHPC group, and I'm sure they'd be happy to take them under consideration.
Okay. All right. And that was not just to me, that was to the whole, I'm just pointing it out, right? Pointing out the bleeding, that's one thing I'm good at, is pointing out the obvious. That was aimed at the entire group here on the call.
Yeah, this question was, I mean, it started as a question you asked to begin with, Tom. Do we need to do something different, or should we stick with the PICMIG? I think the group is concluding we should probably still try to say it aligned with the PICMIG, and I agree with that. I mean, I agree with it.
Yeah. I like that too. Okay.
Yeah, the other thing I can do is talk to the chairman of the group to see how much information he's willing to share at this point.
Okay.
And see if he's got a presentation or something like that that covers the features and improvements that are in the ComHPC, and see if I could bring that over to this group.
I got an interesting question here, maybe for Archana. Do we have any kind of a special relationship with the PICMIG group, or would it make sense for us to, let's say, lasso folks from network and telco, and or maybe just an open invitation to have a kind of a workshop or a meetup or a webinar, some type of a information exchange around CPU modularity desires at OCP and the work that's going on in PICMIG on this new ComExpress form factor.
Absolutely. God, I think that would be a fantastic idea. We do all sorts of cross collaboration across other organizations. I know we've done it with PCI SIG. We've done it with like ASHRAE. We've done it with TIP, ONF, ONL, right? I'm sorry, ONF and Linux Foundation. So yeah, absolutely. I don't know whether it makes sense to do anything, early next year, or if they have any kind of workshops going on, we can certainly present. And then if we have any kind of telco workshops, we can ask them to present. Absolutely. Just let me know how and where to connect the two. And I'm happy to have that conversation.
Okay. So maybe I can, if I can be so bold, Michael, I'm going to give you a homework assignment to make like an e-introduction and see if we can connect the dots so that we could, I don't know that it has to be a big, long drawn out thing. I think just, a call like this one with some application sharing and the ability for the OCP folks and for the PICMIG folks to kind of tee up applications, uses, plans, and how we might coordinate more closely with one another. That could be a great thing.
Well, I'm sure that PICMIG would be interested in anything that would increase the size of their potential market.
Yeah, I would guess.
So Michael, I just, in the chat, I just sent you my email. Please, set up an intro or a call, and we can get myself and the telco group, as well as invite Bill Carter, our CTO, to attend and see where we go from there.
Okay, I will take care of that.
All right.
Sweet. All right. So then, is there any other discussion around CPU modules? We've had a lot of talk about ComExpress. Is there any, I hate to ruin a good thing. It sounded like I was hearing a fair amount of consensus around that. Are there any dissenting views? Do people think that ComExpress is too expensive or too constraining, or that or that there ought to be something else in either every case or corner cases? Okay.
Go ahead. It sounds like you.
So I was just about to call that a strong consensus, but.
Well, so I think, Tom, it is probably a strong consensus, but I guess my only question is, are there other alternatives? I'm not aware of any that are mainstream and widely adopted, and I've been doing this stuff for a long time, but is there another alternative to consider? I'm not aware of. No.
Well, for example, when we were sort of batting around ideas at a larger form factor, one of the things I was proposing is to have a look at things that have already been contributed at OCP, and one of the common form factors for a modular CPU seems to have been either one or two sort of quasi-standard PCI Express slots, right? So that a module might look like a PCI Express card. And it may have, if you look at some of the Facebook, what's it called again? Dang it! They had the little server that had 4 cards stuck in it with Xeon.
Is that the mini pack or the mini switch?
No, it was old. It was old. This is a couple of years back. And they had 2 variations of this thing, and I hate it when I draw a blank like that.
Was it the backpack?
No, this was a server.
This is a Tioga Pass. I'm trying to think. I think it was
Tioga.
So regardless, it sounds like
Voyager.
Other OCB contributions that have been made that we could potentially leverage. What you're trying to say, Tom? And
that is correct.
To me, but are those in? I mean, are they really in real competition with, the adoptance rate of the PICMIG specifications? And the reason why I bring this up, and I know this ODM is on the call, that they want to leverage their value and they don't want to be doing something custom or off the reservation. And if they could see synergies aligned, between something that is multiple industry standards. And to me, I personally think we even need to make the relationship tighter with PICMIG if we decide to go down this and say, hey, if we're doing modular solutions, PICMIG is our choice, and we're going to influence PICMIG to make the right decisions that make this work for us. That's my view on things, but that's, again, my opinion. I don't know how others feel, but I do think this is the right way to go.
Okay. I don't disagree with you. I guess the observation I was trying to make is it's not just a single contribution, but that the sort of quote use of the standard PCI Express Goldfinger's connectors, sort of in a double width, wound up getting done for a number of CPU cards and a number of riser cards. It seems to be a fairly common approach.
Yeah,
and I don't know.
I've done that for years, and if you guys remember the OCP mission that was done through the Telco group for the UCPE, that's exactly what we did for, because I was the architect on that implementation. That was exactly what we did, because we used a by
right.
Goldfinger essentially to be able to do that. Again, I think that's a one-off, and we've seen that be a one-off versus what the industry standard is adopting, which has traditionally been PICMIG.
Okay. Well, I'm just, trying to make sure it's interesting. In a group like this, consensus has to be tested. And, understanding if people had reservations or preferences, or, they might have been a comment that would be a significantly cheaper solution. Those are all things that like to give airtime before we, set something in stone.
Agree. And I think all those things you said are probably true. It may be more elegant, it may be cheaper, et cetera. But if we can't achieve the sales volumes to make it a viable business, it doesn't matter. So,
Right. Okay. So I think is there any other questions or comments about CPU modules, or shall we move on to the third item? Okay, so the server was Yosemite, by the way. Finally the trap worked in my head. That was the contribution I was thinking about. Now on item 3, suitability of the NIC 3.0 as a module for WAN interfaces. This is a topic that came up during the development of the Universal CPE spec. I think the first version, the one we have now, didn't have this sort of externally replaceable modular WAN interfaces in the spec. But we had talked about potentially making use of NIC 3.0 as a basis for that. And we had gotten as far as having a joint call with the NIC group and learning that, while the NIC 3.0 has lots of PCIe lanes, up to 32, a lot of the other interfaces that get used on WAN devices, things like USB or I2C or whatnot, there might not be spare pins or LANs for those types of things to be added to an existing NIC 3.0 spec. So I think what we wound up with is that it may be necessary to have something similar, but not exactly the same as NIC 3.0 for WAN interfaces. And I wanted to see, what were people's thoughts about moving forward with a work item in the telco group that would allow us, in the same way we talked about modularity on 1 and 2, to think about having WAN type devices that would or interfaces that would plug into network equipment in a standard form factor. That make sense?
Well, I'm game. Let's start the conversation. This is near and dear to me, Tom.
Yeah. Okay.
So my first thought is along the lines of and hopefully this spurs more conversation, but my first thought is along the lines of what we talked about in the previous conversation, is that we need to define something that is being adopted industry-wide. With that said, clearly the OCP Mezzanine 3.0 is absolutely getting some traction. There is some other modules that's being proposed and being built off of the PCIe interconnect. What if our first thought process is to say, hey, we don't need all those 32 lanes to be PCIe. Can we take and do much like the M.2 specifications have been written and choose, hey, for this is a type such and such, and this is a type such and such, and create a few different types potentially that people can plug in to repurpose some of those 32 lanes in order to be able to, into a 3.x or a 4.0 specification that allows these things to be, multiple things besides just PCIe devices. That would be my
right. I like that idea, and frankly, it makes a lot of sense. Not only in network equipment, right? That a number of the servers that we've had a look at recently have system on chip designs that have a number of Ethernet ports built in there, and when you try to make use of those servers in a constrained form factor like Universal CPE or the Open Edge environment, a lot of times there's not the front faceplate space for both the onboard NICs and plug-in NICs as well. And so having a connector that would allow you to alternately have a very, let's say, a very low-end, cheap board that would extend the on-SOC Ethernet interfaces, or alternately connect to the PCI Express lanes to host a much more high performance or accelerated or what have you type of interface alternately. Seems like it would benefit those kinds of server designs in addition to what I call straight up network element designs, where you may have an ASIC that's looking for, you know, SerDes out to a card and not necessarily for PCI Express lanes. Does that make sense? Is that where you were going with that comment, Dirk?
That's exactly where I was going with that comment, Tom. 100%. I guess I'd like to hear from some of the equipment providers and other folks on what their thoughts on that is. If they agree or disagree or.
Yeah, I mean, if we're talking about standardizing a modular I/O form factor, especially from a network equipment perspective, supporting interfaces to the compute subsystem other than PCIe would be beneficial. Obviously, you'd avoid the whole PCIe to, I/O protocol conversion that would need to happen if PCIe was the only interface supported. I'd be in support of a expansion, if you will, of the NIC 3.0 to maybe have some general SerDes lanes that can be mapped to different protocols.
Okay. And do we think that let me ask another follow-on question. Do you think NIC 3.0 is a large enough form factor for typical WAN interfaces?
You're talking specifically WAN or LAN or?
Both. I think I know that in the email I wrote WAN, but in point of fact, I think modular networking interfaces would have been the proper term.
I want to throw out a different avenue on this, or a different spin on this, and what we saw come out of the Universal CPE submission, because I saw several folks actually take and develop multi-wide modules that could still fit within the specification. So they would put 2 or 3 of these connectors and route them out, and then basically build one large module that would go across the front that would take all these different pins onto a particular module to give them extra board density to be able to develop the LAN and WAN modules as they saw fit. So I think that's a way to deal with that particular problem.
Okay. Do you think, let me put someone else on the spot. Oh, and he's already off mute. So I was going to ask you, Paul, if I remember your GPON box design had multiple types of northbound connectors based on, different applications. Do you think that the design would have benefit from having a module where, say, you could have many low-speed ports or fewer high-speed ports on that type of a design?
Modularity, I don't see if modularity beyond the fact that you can populate the pluggables as you wish is useful. There's one point that I stumbled upon already that might make your question seem more obvious. That is coherent interfaces. If I would want to populate these in my box, for the moment there's no way, because they're all in CFP2 form factor, and I would need to ask the hardware provider to create a new version of the box or a new layout, just because you can't fit it in QSFP cages right now. But the interesting question is, just for having even more choice for the uplink optical module, if this would be sufficient reason to to add modularity for the uplink interface with its inherent cost that you don't have only a pluggable cage, but even more modularity with much more complicated mechanics. I'm not sure that this is, from the cost perspective, reasonable to ask for.
Okay.
They go too far in explanations.
No, that was not bad at all. So I think I caught, don't go overboard. That yeah, you could see cases where this makes sense, but don't go crazy on modularity.
Yeah, it's about that. Yeah, it's a compromise. I saw the advent of coherent optics in pluggables. They're available for a certain time now, and they don't seem to migrate in the short or medium term into the QSFP form factor. But in order to allow even this option, I think the cost effect would have been prohibitive.
Mm-hmm. Okay. It did occur to me that there's some uncertainty about the optics form factors for, let's say, the various PON standards that are emerging. Like it looks like we'll have two form factors for XGS PON, and it's not clear if they'll align with, or the choice that was made there will align with 25 gig PON. And it could, but I do note that whether it's a SOC-based approach or whether it's an FPGA-based approach, most of the silicon that supports PON access is intending to be flexible to support multiple speeds and feeds, if you will. And I wonder, maybe a question for the manufacturers is, do you think that having bespoke boxes saying, this box does XGS, this one does 25 gig, and this one does GPON, or a box that has these type of modules where depending on the module you plug in, you get some number of ports of GPON or XGS or 25 gig PON. That seems like another question about, is there a desirability to develop these types of modular WAN interfaces or access interfaces in this case? Hopefully that makes sense.
Well, I see the same question is coming up in our place as well. If you're discussing not really the question that one chip would support 10 or 25G, I think this would be reasonably clear that this SFP Plus and SFP28 mechanics. So an SFP28 would easily be downward compatible to XGS PON, and I have the impression that the 25G PON will be clearly SFP Plus based. So I think this is more or less settled. The question that I see is that dual channel devices are for strange reasons coming back in my place, and there people are proposing to use dual channel XFPs again, which I do not really like because I do not feel this can be a standard for a large community, or dual channel SFP size devices, which are, well, there are two options. There's the very modern for high speed DSFP, the dual channel SFP is the same way as the QSFP, the SFP DD. Sorry, I'm messing up. The SFP DD version, that is simply with the prolonged second connector line, which clearly was originally targeted for high speed 50 and 100G serial, but would nicely fit for dual channel 10G, 25G PON. Or the other one is more or less proprietary addition of or use of the standard SFP 20 or 22 lane connectors for SFP size to use simply the two electrical lanes necessary for each optical component inside. But this seems to be, well, a more tricky compromise as the number of ground lanes seems to be not really large enough for high-speed 10 or 25 gigahertz interfaces. Unfortunately, I'm not the extremely high-speed electrical connector guy that can really rule out this kind of option. But I feel there is at least a need to community discussion to have a reasonable choice among these and not try to put up multiple options and well, destroy the effect of having a common interface for many of us.
Okay, that makes sense. All right. I did notice that we've come up to the end of our call, and gosh, I was worried that we wouldn't have enough to talk about. It just goes to show, right? I'll pause and see if there are any last-minute comments or questions, and if not, I don't recall when our next call is, but maybe Archana can help me with that, and then we'll say goodbyes. So, any last-minute comments or questions? No? Okay. And then Archana?
I see the Open Edge call is next week at 1 p.m. Eastern on the 10th. Okay. And then I'm pretty sure that the next telco call will be rescheduled because it's right now set for New Year's Day. And
it's going to be.
Yeah, with that being a holiday, I have a feeling that it might get pushed out to possibly the week after, so that it's, on, say, the 8th of January instead of the 1st of January. But
that
I will
sounds like the right thing.
Yeah, I will let Sumitra and those guys know, and then they can make the adjustment accordingly. I'm sure that they'll be sending out a note that the January 1st call has been rescheduled.
Okay. So then for those of you that are expecting to come to the Open Edge call next week, we'll look forward to seeing you then. And if you're not, then happy holidays and happy New Year, and we'll see you again in the new year.
Sounds good.
Thanks a lot as well for you all.
And I already sent the introduction letter out to everybody.
Okay, great.
Thank you. Awesome.
All right. Take care, everyone.
All right. Thanks, everybody. Bye-bye.
Take care.
Bye-bye.
Thank you.